Welcome to today's lesson on ethers. So this is the family we're focusing on now. We've done haloalkanes, we've done alcohols, alkynes, alkenes, and alkanes. Ethers contain the functional group of a singly bonded oxygen atom. So like you can see here, oxygen is in the middle of a carbon chain. So I've got a carbon chain on either side and they're labeled as 1 and 2. And that's going to become important because 1 is going to be the shortest of the chains and 2 is going to be the longer of the chains. So it's important that you're counting the carbons to tell which side is shorter and which side is longer because that's going to matter for the name. So a simplest one, so if I want to draw a simple one for you, 1 carbon, oxygen, and another carbon chain on the other side. Again, remembering carbon can only have 2 bonds, so it's going to just be sandwiched. It kind of, I like to call this one kind of like the Oreo cookie. So there are carbons on either side of the oxygen. When we're doing the name, just like I said, so you're going to name the shortest chain first, then oxy, then the longer chain. So we kind of have to do a little bit of digging and see which side's the shortest chain. So here I've got a methyl on this one, and I've got an ethyl on this side. So when I do the name, I'm going to name the shortest chain, then oxy, then the longest chain. But I'm not going to include those YLs. So this is meth, oxy, ethane. And again, the ANE because everything's a single bond. Again, there are molecules that are not all single bonds, but we're focusing only on the simplest structures right now. So we're naming the shortest chain first. So the shortest carbon chain was 1, and then the longest chain next. So your shortest chain should always come first, followed by the longer part. Okay, so taking a look at the ones we've got here. So first thing I want to do is figure out my carbon chains. So here I've got 1 carbon on this side and I've got 3 carbons on this side. So again, I've got a meth on this side. And this time I've got a prop on this side. And then of course I've got that oxygen in the middle. So my name is going to be meth, oxy, propane. Okay, short, oxy, long. Taking a look at this one, 3 and 5. So the name for 3 is prop. The name for 5 is pent. So then my name is going to be propoxy pentane. Okay, remembering short chain first, long chain next. Okay, structures are similar to that of hydrocarbons. Again, basically I'm just putting 2 chains together, separated by that oxygen atom. So the names are going to tell me the 2 chains and then the oxy in the middle. So I don't need any numbered prefixes with these ones because it's always just a chain separated with that oxygen. So there's no numbered carbon that I have to worry about. Okay, so the C single bond O makes them slightly polar, but that is nowhere near as polar as an OH group and not even as polar as a C double bond O hanging into the middle of a chain somewhere, which we'll get into in a few families later. They definitely cannot form hydrogen bonds. So having said that, these are actually the least polar of the derivatives of our hydrocarbons. So alkanes, alkenes, alkynes are definitely the least polar because they don't have any of these other atoms bonded into them. But this one would be the one that comes next. So their boiling points and melting points are only slightly higher than that of the hydrocarbons. So they have the lowest boiling points of any of the other organic families. So just to kind of go over what we talked about, we did haloalkanes, which had our fluorine, chlorine, bromine. We did our alcohols, which had our OH. I'm just going to put chlorine there for an example. And now we've done our ethers, which have our bonded O in the middle. So if I had to rank these on polarity and the strength of those intermolecular forces, alcohols are going to be the most. And then alcohols are followed by the haloalkanes, and then followed by the ethers. So the boiling points of alcohols are very, very high compared to the low ethers. Because of that C bond O, they are pretty much insoluble in water. They are very soluble in what we call non-polar solvents. And because of that, the properties of ethers, they are extremely flammable. So because of those properties, we kind of use them for the following. So were historically used as an anesthetic. So you can, people would put the rags of ethers over their face for doing surgery to knock people out. They are used as a solvent for fats and waxes and oils, so something to dissolve for perfumes. They're used to help start a diesel or gasoline engine in cold climates because they're not soluble in water and they don't mix with water very well. And just a side note there, they're used to purify cocaine, again, to take out any impurities from that. Okay, so just some notes about where we use ethers in real life. And then your practice, of course, very similar to the alcohol practice. So a few molecules to draw and write the formula for, and a couple molecules to name. Okay, keep in mind that you're always naming the short chain first and then oxy and then the longer chain. So I've tried to trick you in a couple of those questions down below. So make sure you're looking at the length of the chain.